Hello and welcome. I'm your host TJ and this is Sci-Fi Quest. Today we're going to talk a little bit about going to Mars. Well, it's an idea right now. If you're looking at this in an ancient archive and we've already been to Mars and back, I may be right, I may be wrong. We'll find out. Anyways, Mars is not close. It's the closest of the planets, but it's not really close. It's about between 33 and 35 million miles from Earth. There are very many considerations as to how to get there. The orbits of Earth and Mars are a little bit different in the sense that they're not in the same plane, but rather they're a little bit off. So it's not just that they're elliptical, and therefore there are times where Mars and Earth are further apart. It's also a fact that they may be in different positions relating to the plane of rotation. So that makes for very peculiar plots for orbits to get to Mars. The way it works is that it takes between 150 and 300 days to get to Mars from Earth, depending on how much fuel you want to burn. The reason for that is the longer the acceleration, the faster you'll get there. But remember, you have to brake once you're close. And accelerating and braking both consume a lot of fuel. So fuel it's going to be one of the things that you want to keep in mind. The other thing is, let's take the shortest route, which is about 150 days. 150 days is just under 4 months. Now, 4 months without gravity is going to be an issue for the astronauts. Also, being cooped up in a small craft. Why small, you ask? Because we have to launch it from Earth. If we assemble it in orbit, it'll be different, just like we did with the International Space Station. The we is as a human race. I didn't do anything regarding that, not even tightening the screws. So that's the we I mean. So the ship is going to have to be relatively small. We've been able to put larger and larger payloads in orbit, and we've been able to put larger and larger payloads on the rockets themselves. Ideally, the Mars project would be a craft assembled in space, in orbit around Earth, and then start from there. It'd be a lot easier, and there'll be less problems. On the other hand, in order to do that, we'd probably need a space elevator, and that requires nanotubes, and it requires all this other technology that we don't have right now. So if we do go to Mars in the short term, it'll probably be in a traditional space mission, which means getting on a rocket, have the rocket blast off from Earth, do a quick orbit, and then out into space. The orbits right now, like I said, take between 150 and 300 days. Humans are by now used to that kind of time in space, so that's not an issue in itself. The issue is that you're going to have all the food that you need for that, so that's 4 months worth of food. You're going to need all the air that you need for that, so that's 4 months worth of air. You're going to need everything for that trip. And remember, you're getting to Mars. There's nothing there. There's no 7-Eleven on the corner. There's no convenience store. So all the food, everything has to be on this rocket. Of course, once the rocket gets to Mars, we're thinking we're going to be doing a little bit of colonizing there, and I'll get into that on my next video. But getting there is going to be extremely tough. Ideally, a spinning ship would be good because it would create a little bit of centrifugal force, so we would get a little bit of gravity. The problem with that is, as I said in a previous video, it would have to be a very large cylinder, plus the fact that you need two, or you'd need to exploit the Coriolis force created by the spinning cylinder, which will turn the craft either one way or the other. And you can, factor that into your calculations for the trajectory. None of this is impossible. It's just a lot of math and physics, but it's not difficult. So that's the considerations that you have to have. How will we get there, and how do we ensure the health of the astronauts en route? Since they're going to be weightless for that long period of time, liquids inside of the astronauts start to be an issue. By that I mean, when you're on Earth, whether you're standing up or sitting down like I am right now, or laying on a bed, at all times you have gravity asserting itself on you. In our case, it's 1G. And what that means is that liquids tend to go down. So your head is clear of liquid unless you have a sinusitis or something. But in space, that's not the case. In space, astronauts in the International Space Station have reported a lot of clogged nasal passages. They get a little bit of disorientation because the fluids in the brain and everywhere else don't move as they expect. There's a really fun video where they make an astronaut spin really hard, and then they stop him to see if he gets any kind of dizziness or motion sickness. Nothing happens, and it's because he is in zero gravity. Our problem is that we are used to standing, and therefore our ears, the part where equilibrium is at, tells us we're standing, which means that gravity is pulling us that way. In space, that's not the case anymore, so that's where things start to get messed up. In short, a very long trip is going to have a lot of challenges for the astronauts from the physical standpoint. And then, of course, given that we can't make a large craft to go from the Earth to Mars, there's going to be the psychological component. Cramped spaces, the same people all the time. Even if it's a sparsely populated mission, 2, 3, 4 astronauts, it's the same for people all the time, for months. And that's just to get there. Then you have the time you have to be there and the trip back. So you better get along with them, people. Of course, there's the whole other issue of sex and so on and so forth, but I'll get that into a much later video. So once we get the people on the craft, get them going over to Mars, we're conscious of the fact that it's going to be physically challenging. We're conscious of the fact that it's going to be psychologically challenging. Then you have to realize that you're going to get there to a hostile environment. I'm going to talk about that on the next video. This is a really short video because I promised myself I would make them only 5 minutes. That way I don't get into all the blah blah blah, problems. So thank you very much for watching. Given that this is the third week in December, season's greetings. If you don't like to hear the MC words, you can stop now. Okay, here I go. Merry Christmas. And have very happy holidays. And I hope to see you next week. If you like the t-shirt, as always, look for them on TeePublic and Redbubble. And keep questing. Thank you.